Right, so now we prove that ADCB is a cyclic quadrilateral. We proved it. Okay, so now the next question is, prove that AC bisects BAD. So we need to prove that these two angles are equal. If the line bisects the angle, it cuts it in half. So we need to try to prove that this angle here is also x. But that's going to be easy now, okay? Because think about it. If you think of the fact that this is a cyclic quadrilateral, then when it goes this way and it makes x, then the same chord BC goes that way. So this must also be x. And then the two are equal. That's it. So we can just say, okay, A2 is equal to x, okay, chord BC subtends equal angles. Okay, because we proved it's a cyclic quadrilateral, so the chord must subtend equal angles, and therefore AC bisects BAD. Okay, so the fact that you know it's a cyclic quadrilateral is going to help now. Right, so the next one is very quick. They just want you to show that DG is equal to FG. And you can just say it actually, because we just proved these two angles are equal, and equal chords subtend equal angles. So you don't even have to prove it. You can just say that DG is equal to FG, and your reason, equal chords subtend equal angles, and we showed that A1 is equal to A2. A1 equal to A2. They're both equal to x. So if the angles are equal, the chords has to be equal. Okay. So now we must find the size of angle C2. But remember now, we know that ADCB is a cyclic quadrilateral. So we can use the properties. So we can now use what we said here, that D2 is 90 degrees, because it's the angle on the diameter. And then we can say C2 must also be 90, because it's subtended by chord AB. Okay, so we can obviously say that will be 90. And we just put in the information. So we're going to say D2 is equal to 90, okay, angles on diameter. And then we can say, therefore, C2 will be 90, and then chord AB. Chord AB subtends equal angles. Okay, in the cyclic quadrilateral. Alright, so the next question is to show that G1 is equal to O2. That's what we're going to try to show, that G1 is equal to O2. This is what we know so far. Okay, and we know that ADCB is a cyclic quadrilateral, which might help. And we got the 90 degrees there, the 90 degrees there, we got 90 there. I think the first thing we can say, if you think about it, is that O2, if you think of this chord FG, go to the center, and FG, the chord FG goes to the circumference. So we can start by saying O2 must be 2x. Okay, because it's the angle at the center, the circumference x. So that's the first thing we can see, is that O2 must be 2x. So now, if we just make some space here, I think let's just start by saying that O2 is equal to 2x. Sometimes with these questions, you just put in what you can see and then you take it from there. So our first step is to say that O2 is equal to 2x with an angle at center. So now we're going to try to figure out how can we show that G1 is also 2x. How can we say that G1 is also equal to 2x? That might be a challenge, but that's what we're going to try to show. So actually, it's not going to be such a big challenge, because remember, AFGD is a cyclic quadrilateral. Okay, it's on the circle. So G1 is the exterior angle. You see, this line is extended. So the exterior angle of a cyclic quadrilateral is obviously equal to the opposite interior angle. Okay, the exterior angle is equal to the opposite interior angle. So we can say that G1 is equal to 2x. We can say G1 is equal to 2x, exterior angle of cyclic quadrilateral. Okay, we can say that. And then we can say, therefore, O2 is equal to 2x is equal to G1. Yeah. So that was it. It looked harder, but actually from what we know, it wasn't that hard. Right, so now we have to show that FBCG is a cyclic quadrilateral. So obviously it's kind of straightforward, this one. We already know that AG is a diameter, which means this angle is 90. And then obviously this angle must be 90. Okay? We already saw it earlier when we said AB is a chord which goes this way, 90, and it goes that way, 90. So we can just say C2 is equal to 90 degrees. I think we said it already, but let's just say it again. C2 is 90 from chord BC, or chord AB. B, so tens equal angles. And then we can say AFG. AFG is 90, and it's angle on diameter. And then we actually showed it. We can say, therefore, FBCG is a cyclic quadrilateral, and our reason exterior angle of cyclic, exterior angle of cyclic quadrilateral. Okay, the exterior angle is equal to the opposite interior angle. So that was